Hi guys, it's me again, Angie, and welcome to another video. So for today's video, I'm going to answer the inside activities in chapter 9. So before that, I'm going to open first my NetAcad. So the first activity here is compare TCP and UDP characteristics. For the instruction, drag each characteristic to its TCP or UDP delivery method. TCP session establishment, sequence message segments, guaranteed delivery, ordered delivery, and flow control. So the others is for UDP. So you have successfully matched each characteristic to its TCP or UDP delivery method. TCP is its abbreviation means Transmission Control Protocol and pronounced as separate letters. TCP is one of the main protocols of TCP or IP networks, whereas the IP protocol deals only with packets. TCP enables two hosts to establish a connection and exchange streams of data. TCP guarantees delivery of data and also guarantees that packets will be delivered in the same order in which they were sent. TCP takes messages from an application server and devices into packets, which can then be forwarded by the devices in the network, switches, routers, security gateways to the destination. TCP numbers each packet and resembles them prior to handing them off of the application server recipient. Because it is connection oriented, it ensures a connection is established and maintained until the exchange between the application servers sending and receiving the messages is complete. For example, when an email using a simple email transfer protocol or the SMTP is sent from an email server, the TCP layer in that server will divide the message up into multiple packets, number them, and then forward them to the IP layer for transport. At the IP layer, each packet will be transported to the destination's email server. While each packet is going to the same place, the route they take to get there may be different. When it arrives, the IP layer hands it back to the TCP layer, which reassembles the packets into the message and hands it to the email application, where it shows up in the inbox. While UDP, or the User Datagram Protocol, is an alternative communications protocol to Transmission Control Protocol, or the TCP, used primarily for establishing low latency and loss tolerating connections between applications on the internet. Both UDP and TCP run on top of the Internet Protocol, or the IP, and are sometimes referred to as UDP or IP or TCP/IP but there are important differences between the two. Where UDP enables process-to-process communication, TCP supports host-to-host communication. TCP sends individual packets and is considered a reliable transport medium. UDP sends messages called datagrams and is considered a best effort mode of communications. In addition, where TCP provides error and flow control, no such mechanisms are supported in UDP. UDP is considered a connectionless protocol because it doesn't require a virtual circuit to be established before any data transfer occurs. UDP provides two services not provided by the IP layer. It provides port numbers to help distinguish different user requests and optionally a checksum capability to verify that the data arrived intact. So let's go back to the course index. So the next activity is 9.2.1.7, which is entitled TCP Connection and Termination Process. The instruction is drag each descriptor to its appropriate place in the image to illustrate the three-way handshake of a TCP establishment session. You have successfully illustrated the three-way handshake requirements of a TCP establishment session. So for the part 2, drag each descriptor to its appropriate place in the image to illustrate the four-step process of TCP termination session. You have successfully illustrated the four-step process of a TCP termination session. This this three this three-way handshake process is also designed so that both ends can initiate and negotiate separate TCP socket connections at the same time. Being able to negotiate multiple TCP socket connections in both directions at the same time allows a single physical network interface such as Ethernet to be multiplexed to transfer multiple streams of TCP data simultaneously. SYN refers to synchronize, ACK refers to acknowledge. Messages are indicated by either the synchronize or the acknowledge but inside the TCP header, and the SYN or the ACK message has both the synchronize and the acknowledge bits turned on the TCP header. TCP knows whether the network TCP socket connection is opening, synchronizing, established by using the synchronize and acknowledge messages when establishing a network TCP socket connections. So let's go back to the course index for the next activity. So the last activity for chapter 9 is 9.2.4.4 TCP UDP are both. TCP are both DNS and SNMP. TCP HTTP is for TCP, Telnet, SMTP, and FTP. So these others are for UDP. You have successfully matched the application layer protocols to their transport layer delivery methods. So what is TCP? TCP stands for Transmission Control Protocol, which is this is a connection-oriented protocol that computers use to communicate over the internet. It is one of the main protocols in TCP/IP networks. TCP provides error checking and guarantees delivery of data, and that packets will be delivered in the other way on the other day were sent. What is UDP? UDP stands for User Datagram Protocol. This is a connectionless protocol that works just like TCP but assumes that error checking and recovery services are not required. Instead, UDP continuously sends datagrams to the recipient whether they receive them or not. So what's the difference between TCP and UDP? TCP and UDP have many differences and similarities. They are the most commonly used protocols for sending packets over the internet. They both work on the transport layer of the TCP/IP protocol stack and both use the IP protocol. So this is the end of my video. Thank you for watching and see you on my next video. Bye.